friends, in previous video we have discussed two span continuous beam where support A and support C both are simple, and then second case we have discussed where support A is fixed and support C is simple. Now let us discuss third case. In this case I have assumed support A, support C both are fixed. Now how to prepare the moment distribution table, that we are going to discuss. Similarly, you are supposed to write joint then member of this two span continuous beam. You are supposed to assume some distribution factor, assume some fix and moments also, because we are going to just focus on how to deal with the moment distribution table. Now in this case, as support A and support C both are simple, no support is supposed to be released, no release moment. All the fixed moments will become initial moment. I once again repeat, initial moment step will be only when either one of the support is simple or overhanging. If both supports are fixed, there is no step of initial moment. Fixed moments are become initial moments, so there need not to be released any support. Directly we can go to the joint B and we can observe the moments at joint B. If you see, in this case the moment at joint B is plus 50 and minus 60, and therefore unbalanced moment is minus 10. Now this unbalanced moment is to be distributed in the proportion of their distribution factor with the opposite sign. So we will multiply this moment minus 10 with 0.3 and zero point 0.7, but while we'll write the moment, we will write with opposite sign. Instead of minus, on both sides we will write plus. So 10 into 0.3, that is 3, 10 into 0.7, that is 7, but you can observe here the sign of unbalanced moment is minus, and therefore when we will balance it, it will balance with the opposite sign. Now whatever the moment you have applied 3 to balance it, will it be carried over to A? Answer is yes, because support A is a fixed support, so half moment with the same sign will be carried over to A. Similarly, half moment with the same sign will be carried over to C. Now joint is balanced, we have done the carryover, we can directly go for fix and moments. So if you will see, you can calculate the value of fix and moments. So here in this way we can solve the two span continuous beam for moment distribution table. Now let's discuss the next case, that is case number 4. You can observe that support A is simple, support B is continuous, and support C is called as overhanging support. There is no support at D. Now how to deal with, how to prepare moment distribution table for this. Now again, similarly you can write the joints as well as member, and you can write the distribution factor. Remember that distribution factor need to be calculated at joint B, where the factor will be 3 by L for member BA and factor will be 3 by L for member BC. But for joint C, you can observe there is a overhanging portion, that is CD, and for that factor is 0. I repeat, for overhanging portion, factor distribution factor is always 0, and the sum of distribution factor is always equal to 1. Therefore for inner member, that is member CB, the factor will be 1. So always remember, when you will calculate the factor at free end it will be 0 and for other end it is 1, and that's why it need not to be calculated, it is always known to us. Now let us assume some value of the fixed moment. Here these values of the fixed moments I have assumed arbitrarily, because intention is to give you idea that how to deal with the moment distribution table. Now, my question is that what you will do? Will it be any step to release? The answer is yes. Support A is a simple support where moment is known to us, that is 0. To make it 0, we need to apply equal and opposite moment at joint A, and whatever the moment you will apply, half of the moment will be carry over at the other joint, that you should not forget. Now, if we see joint C, calculate unbalanced moment. Unbalanced moment for joint C is the difference of plus 60 and minus 25, which is plus 35. Now this moment is to be distributed in the proportion of their distribution factor, which is 1 and 0 in opposite sign or with the opposite sign. Therefore minus 35 and 0. Now this minus 35 moment which you have applied, that need to be carried over with the same sign, half moment with the same sign at the far end. And now we will write the step of initial moment. You are supposed to do some practice so that you will build your confidence. Now just write down the initial moments here. Now if we see joint C is balance, joint A we know that moment is 0 and we have got the moment 0. But if you will observe joint B, it is not balance. Now we need to balance it, and for that we need to find the difference in the moment. On one side the moment is plus 65, on another side the moment is minus 77.5, and therefore the difference of these two moments is negative, and that is equal to minus 12.5. This moment is to be distributed in the proportion of their distribution factor with opposite sign. So this moment is to be multiplied with zero point 0.3 and zero point 0.7, and then unbalanced moment is minus, so we should write positive sign on both sides. Now if we see the far end of joint B, which is A, it is simple and therefore carryover is not possible, and far end of B, which is C, overhanging, that also comes in the category of simple. That's why the carryover is not possible. So joint B is balanced and further carryover is not possible. Therefore we can go for final moments. So just add the moments, that will be the final moments. So in this way we can deal with the problem where one support is simple and another end support is overhanging. So here overhanging support is assumed on the right hand side, that is support CD. Now if you see the other case where overhanging is assumed on the left hand side. So if we see overhanging is assumed on the left hand side, this case we have already discussed. The overhanging is assumed on the left hand side. Let me show you that case. Okay, so this is a overhanging. Now in this particular example you can see overhanging is on the both side. Now how to deal with the overhanging on the both the sides? So for this also what you are supposed to do, write the members here. Now you can observe for intermediate support C, only distribution factor is some number where the addition of factor will be 1. For overhanging, BA is overhanging support 0 and inside BC is 1. On this side DE is overhanging, which is 0, and inside is DC, which is 1. And let us write the fixed moments. These are the fixed moments. Now here we need to find the unbalanced moment and distribute in the proportion of distribution factor. Similarly at joint D, unbalanced moment, of course whatever the moment you have applied, half the moment will be carry over. Similarly at joint D, unbalanced moment and again carry over, and then we will write the initial moments. Here you can see these are the initial moments. Okay, and then at joint C, moments are not equal and opposite, so joint C need to be balanced. Difference in the moment is calculated. This difference is to be distributed in the proportion of distribution factor with the opposite sign. You can observe it is distributed in the proportion of distribution factor with the opposite sign. You can observe over here. And then final end moments. So this is what the way where we can discuss if both sides are overhanging. Okay, now here one side is overhanging and another is fixed. So again, quickly I'll go through this because already we have discussed the same type of the example. So this is what quickly I will show you the moments at this case. Okay, so this is what the table you can practice. Now see here, this is the last case which I have considered, where right hand side support is fixed and left hand side support is overhanging. So in this case also you have to write the factor, then fixed moments. At A it will be 0, at B some value is assumed, and at C some value is assumed. Now first of all, at joint B we need to find out unbalanced moment and distribute in the proportion of distribution factor. Carry over half the moment with the same sign, and then find out initial moments. After that initial moment, balance joint C. So for that, find out unbalanced moment, distribute with the opposite sign in the proportion of distribution factor, and then find out the final end moments. Remember that the joint D is fixed, so whatever the moment you have applied for member CD, half moment with the same side need to be carry over. This is what the way by which we can prepare the table for moment distribution. Here we have discussed only for 2-span continuous beam. In the next lecture we'll discuss how to prepare the table for 3-span continuous beam, where iteration is required or cycles are required. Thank you for watching.